Hello and welcome back to another video on my YouTube. Today we're going to be finding the coefficient of x power of 10 in x cubed plus x squared plus 2 to the power of 8. So where do you begin? We need to start by accepting the fact this is going to be a Pascal's triangle expansion, and for this scenario we'll be grouping x cubed and x squared together, so we can have two terms like this in the expansion, which are a and b. So on the screen here, you can now see the expansion for something to the power of 8. And where a is x cubed and x squared, b is 2. b will always give us the coefficient combined with the coefficients of the expansion. So if you can see 70 times a to the power 4, b to the power 4, a to the power 4 will give us an x to the 10 that we need, and b will join to the 70 to become the coefficient. So which powers of a contain an x power of 10? When we have a power of a, which is x cubed plus x squared, to the power of n, it is another binomial to expand, and this will give us the x to the power of 10. So which values of a to the power of n are too small to contain powers of 10? It's these ones, and I'll explain why in just a moment. I'll be expanding a to the power of 3 for you so you can understand. A to the power of 3 is this in its form, and in a more simplified form it is x to the power of 9 plus 3x to the power of 8 plus 3x to the power of 7 plus x to the 6. So why can't this ever contain a power of 10? It's because the maximum power will be x cubed cubed, which is x to the 9, where the minimum power will always be x squared cubed. So the cubed is a reference to the n in a to the power of n, whilst x cubed and x squared are references to the parts of a. So you can see that on the screen there. So using the same logic as before, which ones are too large to contain a power of 10? It's these ones. So we'll take the smallest one again. We get a to the power of 6. So what's the minimum and what's the maximum? We only really care about the minimum because it is x squared to the power of 6, which is x to the 12. And that will be the last part of the expansion. So what do we have left? We have 70 with a to the power 4 and b to the power 4, as well as 56 with a to the power 5 and b to the power 3. Essentially what we've been doing is adding 2's or 3's to get a power of 10. A to the power of 3 was too small because there weren't enough 2's or 3's, whilst a to the power of 6 was too large because there's too many 2's or 3's. So what we have to do is look at the power of a and determine how many 2's or 3's we'll get. So for example, in 70 a to the power of 4, we get 4 options of 2's or 3's to get to 10. And this is quite obvious. We use 2 3's and 2 2's, which is 4 numbers in total, and this equals 10. So in the fourth row of Pascal's triangle, the coefficient is 6, and we have x cubed squared and x squared squared, and this gives us 6x to the power of 10. Meanwhile, for 56 a to the 5 b to the 3, we get 5 2's, because 5 times 2 is 10. And so in the fifth row of Pascal's triangle, the coefficient will be 1 for 5 2's. And we can have x cubed to the power of 0, which is also 1, and x squared to the power of 5, which is x to the power of 10. So when we have this here, and we've expanded it to get x to the power of 10, we can simply ignore all the other terms in the expansion of x cubed plus x squared to the 4 and x cubed plus x squared to the 5. So we can just replace it with this. 70 times 6x to the power of 10 times 2 to the 4, added to 56 times x to the 10 times 2 to the 3. And this is the way we get the x to the power of 10 coefficient. Now we're going to simplify this. We're going to multiply each side and we're going to add them together. 70 times 16 times 6x to the 10 and 56 times 8 times x to the 10 is equal to this. 6,720 x to the 10 add 448 x to the 10. And in total it comes to this, 7,168 x to the power of 10. So thank you for watching this video today. Please leave a like and subscribe, and I'll see you next time.